All right, hello everybody. We're going to be going over a few more pieces of sound and light today. So a few more ways that waves can interact and behave with each other. Today your job is to complete this slides presentation and then complete the day 6 exit ticket, which is found at the end of the slides, and then answer that on Google Classroom by 2:30. So today we're going to be looking at how different waves behave related to sound and light, or we're going to specifically be looking at specific behaviors of those different waves. So the first type of wave behavior is something called wave diffraction, and that's when wave energy is bending around a corner or a barrier. So if we have a small opening in an object, the wave will bounce back off of the object, but if there's a small opening, it will continue to pass on through, as you can see in the illustrations down here below. So the wave will continue through, and then it will actually expand out. So check out this YouTube video. Hopefully that'll help you with diffraction. Light diffraction is even a little bit harder to understand, but it's kind of cool. And there's some really cool demos you can do with it. Diffraction is also kind of part of the fuzziness on the edge of your finger. Um, you can also get a laser bending around a pencil. There's a lot of diffraction going on, and we can do a lot of really cool things with diffraction. So the next thing in is interference, and that's what happens when two or more waves arrive at the same time. So if you think about it, you jump in a pool at the same time as somebody else, all right, those waves are going to reach each other at some point, and then there's going to be some sort of interference that occurs. And there's two types, constructive and destructive. So constructive interference means that both waves are going to add up together, and destructive means one's gonna cancel out the other. So we're gonna have no wave kind of action. So constructive means we're going to amplify the energy. So we're going to have wave A coming from the left, wave B coming from the right. And when they meet, the amplitude is actually going to be doubled. So we're going to have A plus B, and that's perfect construction, right? We have no energy lost. Both of them are adding up to the same peak and then going on their other way. Now, if the waves are traveling in opposite directions, so let's say you had a slinky or a jump rope or something, and you had waves going in opposite directions, we have A going to the right, B going to the left. When they meet, what's actually going to happen is they're going to cancel out. So remember, amplitude is that distance from the equilibrium point or the center point. So here's the center, and if both trough and peak, right, are equal to each other, when they meet, it will cancel out to zero, and then they'll still continue along that way. So if you got a cool pair of headphones, the new Apple AirPod Pros actually do this really well. It's cool. Um, they have noise canceling interference, and what they'll do is they'll try and pick up things going on around you, and they'll produce waves that offset the waves coming in, and that allows for kind of that silence because we get that destructive interference. So we have sound waves coming in and the sound waves going out, matching up on opposite sides, right? And that allows for silence or close to silence to occur. Resonance is the ability to vibrate and vibrate by absorbing energy from an object's natural frequency. Um, there's a lot of examples. There's actually a really big bridge in Tacoma, Washington that collapsed, and that's just one example. You can put these are really cool salt on resonance metals, so they'll vibrate at a certain resonance, and then you'll see the patterns that occur. So this video is really cool. You watch it, you can see that depending on the frequency that they're vibrating at, you're going to get different things to form. If you've ever seen or heard of somebody breaking a wine glass by singing at the right pitch, right? This is going to be part of that idea that you can match a pitch and you can actually increase that frequency, and then you're going to make it a little bit louder. The Doppler effect you might think comes from like the Doppler radar that we use for weather. It's a little bit different than that, but the Doppler effect is the apparent change in pitch as objects moving towards you or away from you. So if you think about if you hear an ambulance or a fire truck or a police car, driving down the road, and as that car gets closer and closer to you, the pitch of that siren gets higher and higher and higher, right? So you get like a whining noise. And then as they go away, it starts to fade out and it gets lower and lower and lower. And that's because of the Doppler effect. There's a really cool video here. But the Doppler effect really, I mean, as that object is moving towards you, it's making a pitch. And as it's moving, it's actually reducing the distance between the leading edge of the sound waves. So the ones in front of the speaker are going to be um, perceived as a higher pitch because the object's moving and it's making noise. Those sound waves get really tight together. So when we think about tight together sound waves, we think high pitch. And then the opposite is true on the back end. So as that car is moving, or that ambulance or that fire truck, it's actually going to get lower because the car is moving in one direction and then the sound waves going to the back are going the opposite direction, making those apparent pitches lower because the frequency would be lower. So here's just kind of an example. You see as the car is moving that direction, the sound waves get tighter and tighter and tighter. And as it's moving, if you're back here, the sound waves get further and further apart. And so as the car moves towards you, the pitch is going to go up. And as it goes away from you, the pitch is going to go down. All right. So define these three terms: resonance, diffraction, and interference, and answer that for your exit ticket. And we will see you guys later. Have a great day.